Alrighty, we are on the last section. 1.7 absolute value equations and inequalities.
Hey, maybe I'll give you a call sometime. Your number still 911?
Absolute value is the distance from 0, and it will always be positive, or at least 0. So absolute value of x is basically what it looks like. Solving an absolute value equation, you need to set up it if it's positive, so it's just basically putting in two equations. You set up what it looks like, and you set up if it had a negative final answer.
Hello? Anybody home?
So x minus 9 equals 5, and x minus 9 equals negative 5. So you solve both those equations to see what you get. So you'd add 9 in both of them. So you'd end up getting x equals 14 and x equals 4 as your answer. So notice if you put them both in, you will still get the same answer when you put them both in. So two answers actually work for the absolute value. Properties of absolute values and inequalities. Absolute value is less than b. That means it's less than b and it's greater than negative b. Okay? And what I mean by that is if you have some number x that is less than 4, so 3 works, and negative 3 works, 2 works, and negative 2 works, 1 works, and negative 1 works. Okay, so everything less than 4, but also greater than negative 4. So everything in between 4 and negative 4 basically will work. The absolute value of a is greater than b means that everything greater than a greater than b will work, and everything a less than negative b works. Okay, so see what's happening here with the signs. You flip the sign and you make it negative is basically what we're saying here. So when it's less than, see how we flip the sign and we make it negative. See here, you keep what you have and then you flip the sign, you make it negative. That's all you're doing here to solve inequalities. Alright, that's basically what you do. It's a little formula there. So whenever you're solving absolute value inequalities, you just flip the sign and you make it negative. So that's all we're basically doing here. If it is a less than sign, though, you just kind of make a sandwich problem out of it. See how that's a sandwich problem? You write down exactly what you have, but then you put the negative of that number on the outside. And if it's greater than, that's when you write two separate problems, right? If it's greater than, I write down exactly what I have. Then I write down exactly what I have, but I flip the sign and I make it negative.
Wait a minute, Doc.
So this problem
You built a time machine?
right here, we write down exactly what we have.
If you're gonna build a time machine
Right.
into a car, why not do it with some style?
But because it's less than, you make a sandwich problem out of it. So that's why I have a negative 10 on the other side and less than or equal to right in there. So remember, less than signs, you make it into a sandwich problem with the opposite on the outside. So I just subtract 5 on both sides to solve, and I get negative 15 is less than or equal to x, which is less than or equal to 5. So on here, I put a point at negative 15 and a point at 5, and you would shade in between.
We're sending you back to the future.
Example 3. Because it's greater than or equal to, I write down exactly what I have without the absolute value signs. Then I write down exactly what I have, but I flip the sign, greater than, so it's less than, right? And I make it negative. So I solve each of these equations by adding 5. So I get 3x is greater than 18, so I divide by 3. And I get x is greater than or equal to 6. Over here, I add 5 to both sides, so I get 3x is less than or equal to negative 8. Divide by 3 on both sides, so I get x is less than or equal to negative 8/3. So what that means is x is greater than 6, and x is less than negative 2.6. So there's negative 2.6 roughly. So everything that way, everything less than that. There's 6, everything greater than that. So that's how the graph would look.
All systems go, Michael.
Example 4, because it's less than, it's like a sandwich problem. So I can write it separately and flip it around, or I can just write it as a sandwich problem. I add 3 to both sides, so x is less than 3.5. I add 3 to both sides, and I get x is greater than 2.5. So basically my answer is in between 2.5 and 3.5, or like I said, I could have wrote that as a sandwich problem if I wanted to. Just as long as I remember to put my answer in there. And remember less than and less than, so that's why it's curved bracket and curved bracket.
I'm very important. I have many leather-bound books, and my
A cereal manufacturer has a tolerance of 0.75 ounces for a box of cereal that is supposed to weigh 20 ounces. Write and solve an absolute value inequality that describes this. Okay, so we need to take the actual weight, which we do not know, so we're going to call that x, and subtract the average weight from it of 20. And since the weight is not negative, that goes in the absolute value. So x minus 20, the actual rate minus 20, that's in the absolute value because it can't be negative. And that's less than or equal to the 0.75 because that's the tolerance. So when I write this in between the brackets, right, notice because it's less than, it's like a sandwich problem. So I add 20 to both sides. And I end up getting that it has to be in between 19.25 and 20.75. And this is probably something you can do in your head. A cereal manufacturer has a tolerance of 0.75 ounces per box. What that means is it could have more than 20 ounces by 0.75, and it could have less by 19.25, but they won't let a box go by that has 19 ounces in it or 21 ounces in it, if you follow what I'm getting at.
Well, looky what we have here.
So you are a quality control inspector at a bowling pin company. A regulation pin must weigh between 50 ounces and 58 ounces. Write an absolute value inequality describing the weight you should reject. So the average weight, it's in between 50 and 58, so I divide by 2. 54. So the average weight of a pin should be 54. And the distance between 50 and 54 is 4. The distance between 58 and 54 is 4. So that's the tolerance of the pin, is 4. So what it means is whatever that pin is minus the average, it has to be greater than 4 or less than a pin to reject it. So these are the two pins. So what that means is I add 54 to both sides. So if a pin is greater than 58, it rejects it, and if a pin is less than 50, it rejects it. And that is basically the absolute values. It's not too difficult stuff you've went over since you've been in Algebra 1. So if you have any other further questions or concerns, please feel free to let me know.